In this video, we're going to talk about section 8.1, which is called Perimeter and Area. This section is all about two-dimensional figures or two-dimensional shapes. So let's talk a little bit about two-dimensional figures. Two-dimensional figures can be classified by the number of sides they have. All of the shapes that we're going to be talking about today are polygons. Polygon is sort of a blanket word that covers any figure that has multiple sides. So a polygon is a many-sided figure. A pentagon is a five-sided figure. A hexagon is a six-sided figure. An octagon is an eight-sided figure. And you may notice a pattern here that all those names end in gon, but it doesn't necessarily always go that way. The names of polygons do not always end with gon. One example that you can easily come up with is triangle. So we could call it a trigon, but we prefer the word triangle. And likewise, rather than calling a four-sided figure a quadrigon, we usually refer to it as a quadrilateral. Here are some examples of polygons, or some common polygons. Starting up at the top left and moving towards the right, we have a triangle. Next, we have a right triangle. These are special triangles that include one 90-degree angle, and you can see the 90-degree angle is indicated with the little box there. Then we have a rectangle and a square. Squares are just special rectangles where all of the sides are equal. Then we have a parallelogram. This is where two of the sides, two of the sides are parallel with each other, and then the other two sides are parallel. And then we have a trapezoid. One of the common topics that we need to talk about, or that people talk about whenever you refer to two-dimensional figures, is the perimeter. The perimeter is the distance around a shape. So the perimeter of a two-dimensional figure, it's really easy to find. You just add up the lengths of all of the sides. So let's look at a really easy example to start off with. Here, example 1 says, find the perimeter of the figure below. This is a rectangle. I can tell because obviously it has four sides, and two of the sides are the same. So you can see the top and bottom are the same, and the left and right are the same. Since all four sides are not the same, that means it's not a square. Alright, so let's find the perimeter. Usually, instead of writing out the word perimeter just because we're lazy, we just write the word P for perimeter. Alright, so to find the perimeter, we're just going to start up at the top left, we're going to start at the top, and then we're going to go around to the left. Alright, so perimeter equals 2 feet plus 1.5 feet plus 2 feet plus 1.5 feet. Alright, so 2, I'm just adding this up in my head, 2 and 2 is 4, 1.5 plus 1.5 is 3, so the perimeter is 7 feet. You always want to make sure that you include the units in your answer. If you're working on your homework, the units will already be typed in for you. You'll just have to type in the number. Alright, example 2 says, find the perimeter of a rectangular scarf that is 20 inches wide and 4 feet long. Alright, so we have a scarf. This scarf is 20 inches wide, and the scarf is 4 feet long. Now, one really important factor that you need to take into account before you get started on these problems is that the units all need to be the same. Alright, so you have two choices. You can either convert 20 inches into feet, or you can convert 4 feet into inches. I just went with the one that seemed easier to me. Obviously, if you're working on the homework, then you'll want to go with whatever they have the answer in. Alright, so you want to look at the spot where you plug in the answer, notice what units they're using, and that's the units you want to use. Now, to me, it seemed easier to convert 4 feet into inches, so that's what I did. I went ahead and converted 4 feet into inches by doing 4 feet times 12, because there are 12 inches in a foot. So that is 48 inches. Right, now I can go ahead and find the perimeter. Now I'm not going to write all of this out because I know you can figure it out, but just remember that we have some matching sides here. So 20 inches, that's going to be the same width as the side on the left, and 48 inches is going to be the same length as the top. All right, so the perimeter is going to be 20 inches plus 48 inches plus another 20 inches plus another 48 inches, which if you add all of those together, the perimeter gives you 136 inches. Next, the next topic we need to talk about when we are talking about two-dimensional figures or two-dimensional shapes is the area. The area is the number of square units that it takes to fill the interior of a two-dimensional shape. Now we have formulas for all of the areas of different shapes, so I'll show you those in a little bit. But a couple of things I wanted to point out first. Area is always measured in square units, so this is going to be like square inches, square miles, square centimeters, square yards, square feet, anything like that. So the units are always squared, and hopefully you'll be able to see why in just a little bit. The easiest shapes to find the area of are rectangles and squares. All right, so here's the formula for the area of a square and the area of a rectangle. It says let B represent the base and let H represent the height. So the area of a square is just the base squared, so B squared, which is really the same thing as B times B. Right, so B squared is really the same thing as B times B. And then the area of a rectangle is base times height. Here's our next example. Example 3 says, find the area of a rectangular rug that is 6 feet long and 3 feet 6 inches wide. All right, I always like to draw a picture whenever I'm doing these problems just because I think it helps you visualize it more. It's usually easier to do the problems when you can visualize them. All right, so here I have a picture of a rug. So we have a rug that is 6 feet long and 3 feet 6 inches wide. Now, once again, we have a case where we need to have everything in the same units. So let's go ahead and convert 3 feet 6 inches all into feet. We know that 6 inches is half of a foot. So 3 feet 6 inches is 3.5 feet or 3.5 feet. Now I can find the area. Now, just like I said before with perimeter, since we don't want to have to write out area every single time we're lazy, we're just going to use the capital letter A to represent the area. So the area of a rectangle is base times height. So the base here is 3.5 feet. And the height of the rug is 6 feet. So 3.5 feet times 6 feet. Now this is where the square units comes in. Notice that we have feet times feet. That's going to become feet squared. So remember we said area is always in square units. So 3.5 times 6 is 21. So the area is 21 feet squared. Now this might help you if you are, for example, buying a rug to fit in your living room. If you know how many square feet your living room is, you definitely, obviously you wouldn't want to buy a rug that has more square footage than the room that you're buying it for. So this could help you figure out how much of the room your rug is going to take up. Now let's talk about the area of other shapes. We can also find the area of other shapes like triangles, trapezoids, and parallelograms. A trapezoid is a quadrilateral, so that's a four-sided shape with one pair of parallel sides. A parallelogram is a quadrilateral, which is a four-sided shape, with two pairs of parallel sides. Remember, that was the one that was kind of, to me, it looks like a box that's like flying through space. That's a bad picture, but hopefully you get the idea. It kind of looks like a flying carpet. All right, so here are the formulas. Make sure you write these down, and it may be a good idea to write down the picture as well, just so whenever you see that picture, then you automatically know that's what shape it's referring to. All right, so the first two are easy. You know what a triangle looks like and what a rectangle looks like. So here we have the area of a triangle is 1/2 base times height. The area of a rectangle is base times height. We already talked about that. It says note A equals area, B equals base, and H equals height. And then here we have our last two shapes, the parallelogram and the trapezoid. Parallelogram, the area is exactly the same as the rectangle, it's just base times height. And then you can see the trapezoid is much more complicated because it has two bases. It has the base on the top here, and then it has another base on the bottom. Alright, so a little bit more complicated. So the formula for the area of a trapezoid, I don't believe you'll have to use this, but just in case, maybe you'll see it in another class. This is the formula. The area of a trapezoid is 1/2 times the quantity B1 plus B2 times. Sorry guys, that was the sound of me getting an email. Forgot to turn my sound off before I started this. Alright, so example 4. This is actually straight off of your homework. This is number 1 from the section 8.1 homework. It says find the area of the figure, round your answer to 1 decimal place. Alright, so we have a triangle here. This is a really easy, nice problem because it's already got the height indicated for you and the base. Alright, so recall that the formula for the area of a triangle is 1/2 base times height. Alright, so let's identify the base and the height. Here's the base down here at the bottom. That's the width all the way from the left to the right. So the base is 9.2 centimeters. The height is 3.8 centimeters. So all we have to do is just plug those numbers in. Now you have an extra number here that we're not going to use. Alright, we're not using that 8.0 centimeters at all. So don't let that confuse you. We're not using that. We only need to use the base and the height. Alright, so let's plug in our numbers. So the area equals 1/2 times the base was 9.2 centimeters times the height, which is 3.8 centimeters. Now don't forget, when you're talking about area, you're going to have square units. So we have centimeters times centimeters, which is going to give us centimeters squared. Or square centimeters. You can say it either way. Alright, so if you plug this in your calculator, you get the area equals 17.5 centimeters squared. I've already mentioned this, but I wanted to talk a little bit more in depth about right triangles. So if one of the angles of a triangle is a 90-degree angle, which is also called a right angle or a square corner, this triangle is a right triangle. There are special names for these sides here. The longest side of the triangle is called the hypotenuse. The hypotenuse is always really easy to find because it's going to be directly across from the right angle. Right, so it's always directly across from the right angle. So that side is called the hypotenuse. The other two sides are called legs. Now, I have them ordered here to where A is on the bottom and B is on the right, but those can be switched. You can label this one A if you wanted to, and then label the bottom one B. That's totally fine. The order does not matter for those two sides. The only one that the order matters for is the hypotenuse. So the hypotenuse is always C, but the legs, you can switch up the order. So the hypotenuse is always C. A and B are always legs. A special relationship exists between the hypotenuse of a right triangle and the legs. This special relationship is called the Pythagorean theorem. It's named for a Greek mathematician named Pythagoras, but this is not the person who discovered the Pythagorean theorem as you might think, since it's named after him. A lot of people knew about the Pythagorean theorem before Pythagoras. It's just named for him because he popularized it. So here is the Pythagorean theorem. It says, for any right triangle, the square of the hypotenuse equals the sum of the squares of the legs. Now they write the Pythagorean theorem as c squared equals a squared plus b squared. I prefer to write this as a squared plus b squared equals c squared, but it's totally your preference. But this is the form that I will be using for the problems that we do in this class. So obviously I haven't changed it at all. I've just switched the order. I put the c squared on the right and the a squared plus b squared on the left. Now let's find the area of the triangle below. We already know the formula for the area of a triangle. So that's area equals 1/2 base times height. So here we have the base. So I'm looking at the picture now. So the base is B. The height is 7 feet. We need to find the base before we can find the area. So since this is a right triangle, we can use the Pythagorean theorem to find B. Alright, so let's set up the Pythagorean theorem. It's a squared plus b squared equals c squared. Now I'm going to fill in what I know. I know that a is 7, and I know that c is 25. So a becomes 7, c becomes 25. B just stays b. So now we have 7 squared plus b squared equals 25 squared. What I'm going to do next is simplify my 7 squared and my 25 squared. You don't have to do this, but I think it makes it look a little bit easier if you do this first. All right, so 7 squared is 49, and 25 squared is 625. All right, so we have 49 plus b squared equals 625. Now you already know what to do next. This is a common step that we do when we're solving equations. We need to get b by itself, so we're going to go ahead and move over 49. So I'm subtracting 49 from both sides. That's going to give me on the left b squared and on the right 576. Now next you're going to see something that we haven't talked about before. In order for us to get b by itself, we need to get rid of that squared term. Alright, so we need to take the square root of both sides, because that's going to cancel out the squared. Right, so square roots cancel squares. Right, so I've taken the square root of both sides. Now let's look at the left-hand side of the equation. The squared is going to cancel with the square root. And now you're just left with b on the left. So we have b equals the square root of 576. So now you want to go to your calculator and find your square root button. Alright, once you found that, let's plug it in the calculator. So we have the square root of 576. It's probably going to open up a parenthesis for you. If it does, just go ahead and close it. So we have a square root of 576 is 24. What this means is that 24 times 24 gives you 576. Alright, so B is 24 feet. I know it's in feet, because if you look at the problem, all of the other sides are in feet. Alright, so now I know the base. So we've only accomplished half of the problem. Alright, now we know the base, we can go ahead and plug it into our area formula. So area is 1/2 base times height. So that's 1/2 times the base, which is 24 feet, times the height, which is 7 feet. Once again, don't forget that with area, since we have feet times feet, this is going to become square feet, or feet squared. So we have 1/2 times 24 times 7 is 84. So the area is 84 feet squared. Next we have a problem from the homework. This is section 8.1 homework, problem number 5. It says a ladder is leaning against a building. If the bottom of the ladder is 6.5 feet from the wall, and the top of the ladder is 10 feet above the ground, how long is the ladder? Right, so here's our little picture. We have a wall or a building, and then we have a ladder leaning against it. So I'm going to fill in my numbers. All right, so the bottom of the ladder, so we're looking right here. The bottom of the ladder is 6.5 feet from the wall. All right, so the bottom of the ladder is 6.5 feet from the wall. So 6.5 goes at the bottom. Also wanted to point out that notice that this makes a right triangle. Right, so that's nice for us because that tells us that we're going to be allowed to use the Pythagorean theorem if we need to. All right, next it says the top of the ladder is 10 feet above the ground. All right, so the top of the ladder right here is 10 feet above the ground. All right, so let's fill in that number, 10 feet. They want to know how long is the ladder. So we know 2 legs, and they want us to find the hypotenuse, which is c. So let's use the Pythagorean theorem. The Pythagorean theorem is a squared plus b squared equals c squared. We know the 2 legs are 10 and 6.5. So go ahead and fill in 10 and 6.5 for a and b. It doesn't matter what order you fill these in, but I'll let a be 10 and I'll let b be 6.5. But like I said, if you let a be 6.5 and let b be 10, you'll get the same answer. The only one that's important is c. All right, so let's go ahead and simplify this. 10 squared plus 6.5 squared is 142.25. All right, so 142.25 equals c squared. Now remember what we did last time to get the variable by itself. Since our variable is being squared, we can get rid of the squared by taking the square root. All right, so taking the square root, that's going to make the squared cancel with the square root. And on the right-hand side, you're just going to be left with c. And on the left, we have the square root of 142.25. Now, let's plug it in our calculator. Now I'm going to close the parentheses. And I have, let's see, it says around a 1 decimal place, so c is 11.9 feet. Next, we're going to move on from triangles and we're going to move to circles. Many people, especially historically, believed that the circle was a perfect geometric figure. It has no beginning, no end. It has total symmetry, and it motivated the invention of our famous irrational number pi. The early Greeks defined a circle as the set of all points in a plane equidistant from a fixed point. Right, so you have a fixed point, and then the circle is the set of all points that are equidistant from that middle point. The fixed point is called the center of the circle. Any line segment from the center to any point on the circle is called the radius. Right, so if you go from the center to any point on the outside of the circle, that's called the radius. That length is. Any line segment connecting 2 points on the circle and passing through the center is called the diameter. Now, the radius and the diameter have a special relationship. The radius is half of the diameter. All right, so let me write that out. Radius is equal to the diameter divided by 2. So it's half of the diameter. Now, instead of calling the distance around a circle the perimeter, they call it a different name. So it says, recall that the distance around a figure was called its perimeter. However, as a special case, the distance around a circle is called its circumference. Here are the formulas for the circumference and the area of a circle. The circumference c of a circle of radius r is c equals 2 times pi times r. So notice that in order for us to find the circumference, we need to know the radius. The area of a circle of radius r is area equals pi times r squared. All right, so once again, we must know the radius in order for us to find the area of a circle. This is a problem straight off of your homework. This is section 8.1, problem number 2. It says, consider the following figure, round your answers to 1 decimal place. So it gives us a circle, and it tells us that the diameter of the circle is 5 miles. It wants us to find the area and the circumference of the circle. So we already know that the area of a circle, the formula is pi times r squared. Now, in order for us to do this formula, or in order for us to use this formula, we need to know the radius. The diameter of this circle is 5 miles. The radius is half of the diameter. So the radius is going to be 5 divided by 2 miles, which is 2.5 miles. Now that we know that the radius is 2.5, we can find the area. So the area is going to be pi times 2.5 squared, so the radius squared. So you're going to plug this in your calculator. Make sure you know where the pi button is. Just like I said a couple of videos back, if you're having any trouble finding one of the buttons on your calculator, you can either email me, send me a picture of your calculator, and I'll show you where it is, or you can Google the name of your calculator and then say like pi button, and it should pop up with either a video or a picture or some link to a website where it'll show you where it is. Alright, so pi times 2.5 squared, I'll let it run through that again. Pi times 2.5 raised to the second power equals 19.63. Alright, this said round to 1 decimal place, so this is 19.6 miles squared. Remember, area is always square units. Now let's find the circumference of the circle. The circumference of the circle is 2 pi r. So 2 times pi times r. Alright, so we already know everything that we need to know to find out the circumference. So we're just going to plug in. Our radius is 2.5, so 2 times pi times 2.5. That's going to give us our circumference. So rounding to 1 decimal place, the circumference of the circle is 15.7 miles. Circumference and perimeter are always just regular units, and then area is always square units. So 15.7. Now, luckily, on the homework, you will not have to have that memorized because they will include the units for you, where I've just circled that. But on the final, you'll need to be able to select the correct option. So it'll be multiple choice, but you'll need to be able to remember the area is always units squared. And that perimeter and circumference are just regular units. Our last problem, this is a hybrid shape. This is straight off of the homework. This is problem number 6. And if I could be wrong, but I'm thinking you may have this exact same picture. But you may have slightly different numbers. Alright, so let's see. This is called a hybrid shape because it's made up of 2 different shapes. So I'm going to start with part B because this is the easier part. So part A is to find the area, part B is to find the perimeter. I'm going to do part B first just because this part's easier. Alright, so to find the perimeter, we know that we just go along the edges and add up all of the links that are on the outside. I'm going to start with 9 and move to the left. Now, I'm not going to include this length right here because that's just telling me that the distance from the very bottom of the shape to the very top is 13 yards. So I'm just going around and I'm going to add together 9 plus 6 plus 9 plus 5 plus 5. Alright, so the perimeter is 9 yards plus 6 yards plus 9 yards plus 5 yards plus 5 yards. If you add together all of those numbers, that gives you the perimeter is 34 yards. Now I'm going to move on to a blank page so that I can find part A because that's going to take up most of the page. Let's find the area now. A hybrid shape is made up of two shapes, or this particular hybrid shape is made up of these two shapes, a triangle and a rectangle. You can see the rectangle is on the left, the triangle is on the right. We'll need to find the area of each shape separately and then add the areas together. So I'm going to draw a line there just to show us where we're breaking up the shape at. So you can see to the left of that line, that's the rectangle. To the right of that line is the triangle. Now, since I know that rectangles have the opposite sides of the rectangle are the same, I can go ahead and say that the right-hand side of this rectangle is going to also be 6 yards. So here I'm breaking up my page into a rectangle and a triangle. All right, I'm going to find the area of the rectangle first. The formula for the area of a rectangle is base times height. All right, so the base of this rectangle is 9 yards. The height is 6 yards. So area equals 9 yards times 6 yards, base times height. So the area is 54 yards squared. 54 yards squared. All right, so there's half of the area. Now we need to find the other half by finding the triangle, the area of the triangle. This one's a little bit trickier to find. You have to kind of look closely at all of the information they give you. Now we know that the area of a triangle is 1/2 base times height. So let's look at the triangle. I'm kind of looking at this triangle with my head tilted sideways so that it looks like it's straight up and down like a pyramid sort of. The base of this triangle is 6 yards. Now I don't know the height yet, but I have all of the information I need to figure it out. So notice that if you extend this little line here, then that shows us that that sort of helps you figure out what this 13 yards is here for. Right, so 9 of the yards are on the left. Right, so from here to here, that's 9 yards. Now the other part is going to be the rest of the 13. Right, so from here to here, that's going to be the height of the triangle. Right, so we're doing 13 minus the 9. So what's 13 minus 9? That's 4. So that tells us the height of this triangle is going to be 4 yards. And I kind of wrote it sideways because I like to look at it sideways, so it looks more like a triangle to me. All right, so the base is 6 yards, the height is 4 yards, so let's plug that in. So 1/2 times 6 yards times 4 yards. So this is pretty easy, you can do this in your head. 6 times 4 is 24, half of that is 12, so the area is 12 yards squared. All right, so once again it's yards squared because it's yards times yards. Last thing I need to do to find the area of this hybrid shape is just to add together each of those areas that I just found. So the total area is going to be 54 yards squared plus 12 yards squared. So the total area is 66 yards squared. If you have any questions over section 8.1 homework, you can always email me, or you can hit that Ask My Instructor button and ask me a question on WebAssign, or you can post in the Q&A copy shop discussion board on D2L, and I'll get back to you as soon as I see it.